Rad Linux. Welcome back to another episode of No Flipper Zero, No Problem. This is a series where I try to reproduce individual features of the Flipper Zero for as cheap as I can using accessible parts and software. In my first one, I made a bad USB device out of a Raspberry Pi Pico, and in the last video, I reviewed NFC Tools, which is an application that allows us to leverage the NFC chip in our smart devices to do some comparable tasks to the Flipper. But today, we're going to be looking at this. This is a little USB to UART adapter. Now, USB to UART bridge is a minor feature of the Flipper Zero. The primary focus of the Flipper is to defeat access control mechanisms. But this is a microcontroller. It has exposed GPIO and USB. So it's a nice little fun feature that they've added in that we can do USB to UART's bridging. Now, if you've ever played with a Raspberry Pi or like an industrial ARM board like this, then you might be familiar with UART as a feature. A lot of times these boards will have exposed GPIO. Some of those pins will be UART, and it's a well-documented way for us to interact with these boards. Sometimes, these microcontrollers and different little boards might never even touch a network. There's also a lot of troubleshooting benefits to UART in that you actually see everything on the console from boot, and you see some information that even the operating system will never actually see, things that happen before the kernel is loaded. So there's advantages to development, but there are also other reasons to play around with UART. So a lot of embedded devices, a lot of things that rely on an SoC like this here are going to have UART on them. And that's because usually in the factory or something, they're going to do some testing, make sure the devices are working properly, maybe a little bit of development, but they're not usually going to ship with the headers populated. We're usually just going to have some empty UART holes, and we're going to have to solder something in ourselves in a best case scenario. In a worst case scenario, they might try to dissuade us by doing things like putting a bunch of solder in the holes, which is what happened in this case, and explains why it's such a janky job. You'll see that when we get up close to it. Yeah, but this is great. So this is really helpful because, like I said, we can see the boot, so we can retrieve a bunch of vital information. And in a best case scenario, you might just find that there's an open, shell, root shell available. So without further ado, let's get into it. We're going to look at the board over here first. And so we can kind of see here, let's see if we can get the right angle again. You can see that there are kind of four little circles in that rectangle here where my wires are. So there's four little ports, little terminals there. All the way on the right is power. The unpopulated one, or the one I don't have a wire in right now, is power. The other three are transfer, receive, and ground. So very simple serial connection. Power, again, is optional, but you can power your board as long as the power available from your device is enough. I don't think that 3.3 or 5 volts will be enough for a board like that. I've actually never powered a board through that. I've heard word, pray tell, that you can. Now, while this is unlabeled, and there is no standard to which UART terminal is which, you're going to have to use a multimeter to figure that out. At the very least, this is well labeled. So let's see if we can get in here. You can see we have 3.3 volts, 5 volts, transfer, receive, and ground. So I'm just going to wire that up really quick, and then we're going to come back to a terminal. Okie dokie. So I have my board all set up. I have my USB to UART adapter, or UART to USB. I don't really know which one is which, but whatever. We're all plugged in. We're all set. Now, I'm in a terminal here. I'm on Linux. Uh, I really want to say that you don't have to be on Linux to hack, but it does make life easier. It makes a lot of sense once you start getting into it why Linux is the preferred tool of hackers. And if you don't use Linux, then at least consider installing like WSL or like Windows subsystem for Linux, because I think that's gonna make your life easier. But I'm gonna go through and we're gonna do this in Linux, and hopefully you can translate it to your operating system of choice. I would hope so, at least. So we're going to quickly show ls-dev. This is where all of our ability to interact with external hardware lives. And we're looking through our TTYs, and what we really want to look for is TTY USB. So most of the time, these dongles are going to end up being TTY USB, and then whatever order, if you have other devices that also can access TTY USB, then you might have USB 0, 1, 2, 3, whatever. In our case, we're just TTY USB 0. If you're using a flipper, I think it's TTY AM 0 or AMMC 0. I can't remember exactly what it is, but it's a little bit different. So just, keep an eye out for that. Now, we're also going to use a piece of software. Now, I like to use Minicom, but we can use Picocom, we can use Screen, we can use a bunch of different options. Use whatever you prefer, but I like Minicom. We're going to do Minicom TACAS. It's going to bring us to our setup. We're going to set up our serial port here. I'm going to go to /dev TTY USB 0. Perfect. And I'm going to turn off flow control, hardware flow control, because I don't think there is any hardware flow control here. And so when I was trying to use that earlier as a default, it was not registering my keystrokes. I think that has to do with the way that the UART clock synchronizes. I'm not 100% sure. I don't truly get UART all the way. I just know a little bit about it. So what we're going to do now is we're going to apply power to the board. So I'm going to plug my board in. There we go. So you can see right here, this is the bootloader. This is a CFE bootloader for Broadcom devices. You can see that there's interesting information about where certain things lie in memory that can be really beneficial if you're trying to flash a new firmware onto it. I seem to have borked this board. I really do seem to have borked it. It's going to stop here and it will stay here, and this is not where it's supposed to end. I can kind of force it through if I like jam a bunch of keys incorrectly, but this is where we are. However, you can see that indeed there's a lot of information that's just flying out from the very moment I applied power to the board. This can be really beneficial in the world of hardware hacking when we're trying to, find ways into a device, ways that we can alter, tweak, rearrange a device. And it's a really powerful tool. It's great to use one of these. One of these little dongles is maybe $5, $5 to $10, and it's nice because you can kind of burn them up. There is a little bit of a risk. We're using voltage. If you're trying to use a device that's voltage isn't properly matching this adapter, then you can have problems. You might also have problems if you're using like faulty hardware, right? That's outputting a voltage you don't expect. Then you could possibly burn up the device or your USB port or your motherboard or whatever. So it's nice to use something like this and not risk a $169 device for something that you could use a $5 dongle for. But that's it. That's USB to UART adapting with this nice little device, and it's really straightforward, really easy. Go out, try it out, figure it out. You can find a lot of these Wi-Fi routers for free to like incredibly cheap, and it's a great way to get yourself into hardware hacking. It's just really fun, fun way to start understanding the world of embedded technology. So thanks again for hanging out. I'm Rad Linux, and maybe I'll see you again next time.